Welcome back to my channel, students. It's a Crash Radio Physics. Now we are discussing about the Newton laws of motion. The subtopic, what we are going to learn today is the frames of references. Frames of reference. First of all, we have to understand what is the frame of references. It's a very simple thing, students. A frame of reference is an imaginary coordinate axis system in which the motion of the body can be observed. It is the imaginary coordinate axis system in which the motion of the body is observed. Here I am speaking with you, I am observing the motion of the bodies which are around us or around me. Here I am taking my frame as the ground frame. Okay, the ground frame, earth frame is the ground frame. By taking earth as a frame of reference, I am observing the bodies. Okay, it is the frame of reference. It is the imaginary coordinate axis system in which the motion of the bodies can be observed. Generally, these frames of reference are classified into two types. The number one is inertial frame. Okay, students. The first frame is known as inertial frame and the other one is the non-inertial frame. Let us discuss about what is this inertial frame. A simple answer, students. It is the coordinate axis of system in which the Newton laws are valid. It is the imaginary coordinate axis system in which the Newton laws are valid. We call it as inertial frame of reference. How they are valid and how can we say the Newton laws are valid or not? A simple answer, students. Any frame of reference which is at rest, okay, if the frame of reference which is at rest, we call it as the inertial frame of reference, or the frame of reference which has the uniform motion, students. The frame of reference which has uniform motion is known as the inertial frame of reference. Uniform motion, you know that when a body is moving with uniform velocity, its acceleration is 0. Okay. Here, any frame of reference which is at rest or moving with uniform velocity or executing the uniform motion is known as inertial frame of reference. The best example for inertial frame of reference is Earth. Earth is the example for inertial frame of reference. But I said the frame of reference, inertial frame of reference means it must be in rest. It should be in uniform motion. But we know that Earth is in motion. Okay, and it is moving along the circular path. Yes, it is moving. But the velocity of the Earth is changing in direction all the time. Okay, then automatically an acceleration has to be developed. Yes, it develops. If we consider the motion of the body, Okay, students, the acceleration which is produced is quite negligible. That's why we are neglecting the value of acceleration. When you compare the size of the earth with us, it is negligible. That's why we are considering earth as inertial frame of reference. The same thing goes with the uniform motion. Okay. And we can define the inertial frame of reference like this. It's the frame in which Newton's laws are valid. It is the inertial frame, students. Then after we have to know what is the non-inertial frame of reference. Okay. Okay, students, it is the frame in which the Newton laws are invalid. Or simply we can say, it is the accelerated frame. It is the non-accelerated. What is the characteristic of that? Non-accelerated. Okay, students, it is the accelerated frame is the primary thing. The second is, okay, Newton laws invalid. Okay, students, these are the frames of reference, students. Frame of reference is classified into two types. One is the inertial frame and second is non-inertial frame. Inertial frame is the frame in which Newton laws are valid. In non-inertial frame, the Newton laws are invalid. Let's go detailedly about these, students. In actual practice, these frames of references leads to one more concept, which is known as the pseudo force, students. Which is known as the pseudo force. First of all, we have to understand what is the pseudo force. Pseudo means imaginary or false. It itself saying that it is not the actual force. It is the imaginary. While you are studying about the motion of the body in a circular path, we came across with two types of forces, students. One is the centripetal force and second is the centrifugal. In that pair, the second force, centrifugal, is the pseudo force, students. Actually, it doesn't exist, but it is always associated with forces. Okay, students, these frames of reference, I told you, leads to one more concept, which is known as the pseudo. Pseudo is the imaginary force. Often we come across such kind of forces. Listen my words carefully, students. We are going to learn about these forces in detail right now. When we are talking about the inertia, you have learned that inertia of the body is nothing but its laziness, we said. That means which is unable to change state by itself. Then maybe a question is rising in your brains. He is talking about or pseudo force, but he is taking the example of inertia. Yes, it is related. Now listen to me, students. Let's say it is a vehicle. Okay, students, it must have some tires, isn't it? Okay, it is a special kind of vehicle. The driver is sitting there and a table is fixed in here at the base, and it is the seat where a person is sitting. Okay, students, this car, this vehicle is moving with a velocity which is v. The two, this velocity is uniform. Okay, students, means what? Its acceleration is 0. Obviously, if it is moving with uniform velocity, then we can say the frame is inertial frame. I told you, inertial frame is the frame in which Newton's laws are valid. Means it is non-accelerated motion. It is the example for the non-accelerated motion, and body is moving with uniform velocity. Okay, students. Okay, now say this person is holding a ball in his hand. Okay, students, and is throwing the ball up. Just say it is the open roof car. The ball is moving in this way. Okay, it's moving up and it's coming down. It's a vertically projected body. It is coming back into the hands of that passenger who is throwing the ball. Understanding, students? He is throwing the ball up and it is coming back into his hands again, because it has a velocity which is said to be uniform velocity. Let's say this velocity is 30 meters per second. For example, I am taking. That means what? In every second, the body is traveling a distance of 30 meters per second only. Okay, students? Here, what's happening? The ball has been thrown by him with a speed of, what's that? With a particular speed he threw vertically up. Then again it is reaching in his hands. Actually, what's happening here? Here, when he threw the ball, this vehicle might move a distance of 30 meters in second. Then what could be the path of this ball? Here, the ball is moving up in this way. Okay, when he threw. Then after, due to inertia and other things, it is moving along this direction. Okay, students, when the vehicle moves through a distance of 30 meters in a second, the ball also is moving, what's that, with the same speed, and it travels the same distance. It covers the same distance, which is equal to 30 meters. That's why it is reaching into his hands. Understanding, students? What distance the car covers, the ball also covers with the same distance, because it is the, what's that, inertial frame of reference. That means the body is moving with uniform velocity. Throughout the journey, if it maintains the uniform velocity, okay, students, then what happens? It will reach in again into its hand. It is the obvious thing. You can observe the same thing by sitting in a room. Just sit in a chair. Okay, students, it's the chair. It is provided with the wheels, and you are sitting here in the chair. You are holding a ball. Okay, and ask your friend to, what's that, drag you. Okay, either forward or the backwards. Okay, it is your friend, and you are throwing the ball. Okay, at the same time, he is also making you to move with uniform velocity slowly. Then you can able to catch the ball again. It happens. The same thing is happening here, students. You can do it at home. If you have a revolving chair at home, ask your friend to move it constantly. If it moves, what's that? You can catch the ball very easily. That means what distance you are traveling, the ball also travels the same distance. That means you are in a particular frame. You two are in the same system. That's why what velocity you have, the ball has the same, and as well as the driver. That means you appears to be stationary to each other. Stationary to each other. That's why what distance, what he covers the same with respect to another person who is watching from the outside. Understanding, students? If someone is watching you, he finds you, you are holding the ball again. Okay, students? And now think, what is that? This vehicle is traveling with non-uniform velocity. Okay, students? This vehicle is moving with non-uniform velocity. Watch it now. It is accelerated motion. Okay, students? Let's say it is moving with 30 meters per second. Okay, and it has an acceleration of 10 meters per second. It is accelerating. Means what? Its velocity is changing 30 to 40. It is accelerated motion. Think what happens. It is accelerating, it is non-uniform. Say acceleration is equal to 30 meters per second square. Sorry, 10 meters per second square. What happens? Here the same vehicle is accelerating with an acceleration of 10 meters per second square. That means what? When you throw the body moves up and it is in air. Meantime, what did happen? Its acceleration is, what's it? It is accelerating. It travels a further distance of 10 more meters. It comes along with the 30 meters, but it is falling behind a distance of 10 meters. That's why what did happen? The ball will fall backwards. Understanding, students? When it is accelerating, this body, when you throw the body up, it has a speed of, what's that, 30 meters per second, but it is accelerating at a rate of 10 meters per second square. Okay, in first case what did happen? It is the inertial frame of reference. The velocity is constant. What distance the vehicle travel? The same distance the ball is travel. But here what did happen? It traveled an additional distance of 10 meters. Then what happens? It will, what's that? Reach the same point. The ball will reach the same point. But the vehicle travels 10 meters more. That's why it appears to be falling back. The thing which is behind this is nothing but the concept of the pseudo force, students. Okay, students, here it is accelerating in forward direction with an acceleration of A. Just think it is A and velocity is V. Then what happens? A force will act on the body in opposite direction to the acceleration. This is known as the pseudo force. Let this body has experiencing a force of MA in forward direction, then pseudo force will act in opposite direction, which is equal to ma. Think, if the acceleration is in forward direction, the pseudo force will act in opposite direction. It is the concept of the pseudo force, students. Actually, this force doesn't exist, but it appears to be. Okay, students, I hope you understood what is the inertial frame of reference and what is the non-inertial frame of reference and what is the concept of the pseudo force. Students, let's understand the concept of the pseudo force with a good example. I hope you understood what is the frame of reference and what are the inertial and non-inertial frame of reference. Okay, we are taking one example. Let's say it's a lift, students. Okay, it's a lift and a person is standing in this lift, students. Is the person who is standing, and a pendulum is suspended in the lift. Okay, students, let's see. It is a rope which is connected to the lift and it is the base. Let's say it is moving up with acceleration. A. Call him as the person A. Okay. He is observing this pendulum which has a mass of m. Okay. We are considering it as the lift frame. As you know that it is accelerated one, and simply we call it is the non-inertial frame. Okay, students, this person is observing the mass and we are drawing the free body diagram of this. Here weight will act vertically downwards and the tension is in the string. If we draw the free body diagram, is the point mass from where we are showing the forces, is the tension, and it is the weight, which is equal to mg. Okay, students, and you observe that tension is equal to mg. Say it as equation 1. Okay, it is the lift frame as observed by the person who is in the lift. Now think, it is the ground frame and another person, you say is the person who is standing here, say is B, and is observing the same thing. Say it as ground frame. Okay, students, as observed by the person B. And what he sees? He observed the same, but he found this lift is accelerating up. But this person observed that, was it only the lift is moving, and he feels that the pendulum as and he both are at rest. But he observed the different thing. Say this. It is a free body diagram. Okay, students, is the tension and it is the same weight. As the lift is moving up, here the tension which is in the system is more than the weight of the body. The difference between the two provides a force, that is T minus mg is equal to net force we call it as the MA. And what he observed? He find the tension as T is equal to mg plus MA. mg of MA. Here, a confusion will arise here. Is the second equation. Okay. For the same event, we got the two results. One is T is equal to mg and second is T is equal to m of g plus a. Let's decide which one is the right and which is the wrong. Both appears to be right. If you take it as the accelerated frame, the result is right, ma, that is equal to mg. It is the non-inertial, that means it is non-inertial. It is the inertial frame of reference, then the result is same. Understanding me, students? But we have to stick with one frame of reference. We have to make the result same. Already I told you, a force works in opposite direction, which is known as the pseudo force, which works against the direction of the acceleration of the body. That means, if what's that fictitious force is acting, if you add that fictitious force to the tension that is equal to mg, what we yield in this, then we get the same result. We get the same result. See, this is moving up. Okay, students. Now what we are doing, we are adding one more force which has a magnitude of ma. That too, it is the pseudo force. Okay, students. Okay, then we yield the same result. T is equal to mg plus ma, that is m of g plus a. What you found here is equal to this one. Okay, students. Here I am saying that, what I am saying here, here you can find out the results by using the non-inertial frame also, what you yield in the inertial frame of reference, by adding a pseudo force to the result. By adding a pseudo force to the result here. That means all the time we have to add a pseudo force to the frame which is non-inertial. I hope you understood this concept. Okay, students? Okay, students, I hope you understood this concept. If you get more confusion over, then you can make it very simple. Here if you take this one, the tension is equal to mg. It is the real force which is acting on. I told you, always you have to add the pseudo force in opposite direction to the acceleration of the body. Then it might be negative, isn't it? But what's the free body diagram? Okay, students, it is a T and it is mg. Okay, and the body is accelerating in this direction. The force has to be acting this way. But I said you have to add the force which is against to the direction of the motion. That means the pseudo force must act in this direction and which has a magnitude of ma. Now I think it is clear. That is, T can be had as mg and we add one more force to this. This is pseudo force ma. T is equal to mg of g plus a. The same result you found, what we have here. I hope you understood this one. Okay, students. Then after, we will understand the same thing by doing some examples. Okay students, the concept will be clear after doing few examples in pseudo force.